Hey subscribers, welcome back to another episode of Science with Surback. In this video, what we're going to be talking about is section 13.2, which deals with simple machines. So before we get into notes, there's a couple things, couple objectives that I want you to be able to accomplish by the end of this video. Number one, identify the 6 types of simple machines. Number 2, determine what the 2 principal parts of all levers are. And number 3, determine if an inclined plane changes the force required to do work. And then the final objective is determine what simple machines make up a pair of scissors. So let's go ahead and get started with simple machines. Simple machines are the most basic machines that are divided into 6 main classes. So let me write that down, and I'll pause the video as I do that. Alright, so there is that definition that I just discussed. Now, there are 6 different types or 6 different areas of these simple machines, and what we do is within these particular 6 classes or categories of machines, we define them, or we define them in 2 broad categories known as families. So the two families of simple machines are 1, the lever family, and number 2, they are the inclined plane family. So, we are going to talk first about the first 3 of the lever family, and then we'll talk on the back half here, what is the inclined plane family. So we start out here with a simple lever. A simple lever, all that is something as simple as a crowbar. Now I have a little mini crowbar, and what makes a lever is this. It, just like this crowbar, has a pivot point. This pivot point here is right on the end. We call this particularly the fulcrum. But as I use this side here I have in my right hand, and I pull this up or down, there is a very strong force in comparison to this point I have here in my left hand. So a simple lever is defined as a machine that has a rigid arm that turns around a point called a fulcrum. So I'm going to pause the video and write that down. Alright, so there is that written definition. Now, one thing to take into consideration here is that the endpoint force is multiplied or redirected as the output force. So simply put, a key point here, the input force of a simple lever is multiplied. So when we go back to our simple example here of this crowbar, again, the fulcrum is this point where it pivots. So right here where I'm moving it up and down, that is the fulcrum. Now, right here, I am exerting a force, and on the very end, this left end here, that force is multiplied. So that's why if you've ever tried to rip out nails with the back of a hammer or a crowbar, you can insert a little force, and that force is multiplied, and it helps pull out that nail that is stuck or that you want removed. Now, within the simple lever family, there are 3 classes of levers. And so how I'm going to do this, how I'm going to introduce this is this. I am just going to draw some pictures. So number one, we have our first class lever. And in a first class lever, what we have here is this. We have our rigid arm. And then this triangle is going to represent the fulcrum. And so what happens here is that the input force, if it's inserted right here where I have my pen, the output force is going to be felt on that opposite side. Now, a second class lever, the difference here in a second class lever is that a second class lever is going to shift or alter the location of the fulcrum. So in a second class lever, you're going to have the fulcrum way on one end, and this is the difference. The input force is this upward arrow, so I should put input, and then the output force is going to be seen in this upper direction. So right here, this is the output. Now, the third class lever is again just an altercation of where we put the fulcrum. We put the fulcrum here on the end, but the big difference is our input force is right here at the middle, and then on the outside, the output force, a little bit smaller force here, but it's on the outside. So the difference between second and third class levers is where we put the fulcrum and where the input versus the output force is. Now, to label this clearly here, I should have labeled the input force over here on this first class lever and the output force on this first class lever. Now, I know that was kind of jam-packed there, but we can transition to a pulley. Now, a pulley is a pretty simple machine. We've probably all seen one. We probably used one. I wouldn't necessarily say on a daily basis, but we've used some in our everyday lives. So, a pulley. What I have here is a pulley, and I just am going to use it to tug on this rope. And as I tug on this rope, I can move this weight that's attached to it up or down. Pretty simple machine. So a pulley, by definition, a pulley is a modified simple machine in the levered family. Now, with the pulleys, we have to take a couple things into consideration. The more pulleys we have and how they're oriented gives us a little bit more mechanical advantage, or just our mechanical advantage. So, if we have case one here, if we just have a single fixed pulley, we only have a mechanical advantage, which I'm going to label as MA, equal to 1. So that means our output force equals the input force. Now, if I have the second case here, a single moving pulley. So what that means is as I move the machine, as I move the pulley up, both the weight and the pulley go up and down at the same time. If I have this here, the mechanical advantage is equal to 2. And then if I have multiple pulleys, so let's say I have a fixed plus a moving pulley, just one of each, the mechanical advantage goes to 3. Again, the mechanical advantage of this last case goes to 3. Now, I'm not going to draw pictures because A, I would do a pretty poor job, and then B, we're going to do a lab here that shows you the mechanical advantage for pulleys. So we move to our third simple machine here, and that is the wheel and axle. Now, a wheel and axle is the final portion of the simple machine that belongs to the lever family. And a wheel and axle is made of a lever or wheel that is connected to a shaft or an axle. So, a great example of a wheel and axle is this. Well, actually, I got 2 examples here. The first example is the steering wheel. The steering wheel of the car. As you turn that steering wheel, your car tires actually rotate and move in a pretty dramatic fashion. Another example of this is a screwdriver. Kind of hard to think about this, but a screwdriver, again, it has a lever, that rigid arm, and as you twist it, as you rotate it, it allows that force to be exerted on that particular screw. So we get the screwdriver as our second example. Another good example here, well, I'll save that example, but we'll talk about it here in class. Now, the first 3 categories that we've all talked about all belong to the lever family. So the last 3 categories that we're going to talk about belong to the inclined plane family. So, inclined planes, think of a ramp. A ramp is going to reduce that upward force that you need to exert, and it's going to make you walk a longer time, but exerting that less force or that less work that you have to do. And so with our inclined planes, a simple inclined plane, we're going to keep this simple, and we're just going to say this is a ramp. So a ramp, again, my poor depiction of a drawing is going to be this. Let's say we have a sidewalk, and then we have a ramp that leads up to a series of stairs. Again, this ramp is a simple machine. So I'm going to label that because I know my drawing's pretty poor. And I'm going to show you an example. So a ramp is something as simple as a ruler here, and it's going to be propped up against this particular weight. So we've made this simple inclined plane. And what happens here with a inclined plane? The same amount of work is done, it's just done over a longer distance. So let me make that clear here. All right, so what this means, that in a ramp or in an inclined plane, the same amount of work is done. It is just done over a longer distance. So if you've ever seen somebody that has a ramp attached to their house, that ramp is actually pretty lengthy in comparison to the height of the stairs. However, you will do that same upward force or upward work as you would walking straight up the steps as walking on that ramp. It's just done over a longer distance. So we have 4 of the 6 simple machines. We move on to the wedge. Now, a wedge is just 2 inclined planes placed back to back. Couple examples of this, or one real good example, is an axe. Now, I don't have an axe handy on me, but I do have a door wedge. Now, this door wedge, if I put it down here, and it's not very good in this video, but you can see here, it has an incline. The top here where my right index finger is a lot taller than the bottom portion here, and it forms an incline. If I were to put my pin, which is round, this pin would roll down this incline. Now, the definition said, hey, this is 2 inclined planes placed back to back. So what if I flip it up? Do I still get that incline? And the answer to that is yes, because a wedge, by definition, is 2 inclined planes, 2 ramps placed back to back, and that's that simple wedge. We then move down to the last simple machine, and that is a screw. And so with a screw, what you have here is an inclined plane wrapped around a cylinder. So with a screw here, again, everyone's probably seen a screw, but if you haven't here, our screw, as you can see, it's essentially like having a ramp wrapped around this particular cylinder device. Now, what if you look real close, and I have a really small screw here, but what you can see is that, oh, there it is, as it ramps up, that ramp gets you further and further and closer to the top of this screw head. All right, so we've moved on. We've gone through the 3 different types of inclined plane families. We've gone through the 3 different types of lever family simple machines. Now we can start talking about compound machines. And so a compound machine is a machine made from more than one simple machine. So, in those objectives, I talked about how scissors could be used as a simple machine. So I have a pair of scissors here, and what we have is this. Number 1, if we look at scissors, and I'm just talking about this part here that says value, and I move this up and down, this right here is going to be a first class lever, and this right here on the opposite side is yet another first class lever. Now, what we have here also, if you look really closely at scissors, is, and I don't think the video is going to do justice. Oh, there it is. This also has a wedge that is used for cutting. There are two sloped sides, or there's two sloped inclined planes on these particular values. Look at that wedge right there. So scissors here, our example is going to be a pair of scissors. And scissors, why they are considered a compound machine. One, they have two first class levers joined at a fulcrum, a common fulcrum. And then two, the other type of simple machine here is that each of those levers has a wedge, and that wedge allows us to cut that paper. All right, so I know this is a lot of definitions in this particular section, but I hope you've enjoyed this video. I hope you got something out of it. And as always, don't forget to subscribe.